Seeking English S.A.T. Workbook, page 420, problem 1. You may use a calculator. I'm not going to put the graph up because it has too many dots on it. I'll describe the graph well enough that if you really want to solve this problem with just the description, you may do that. But if you have the book, probably just look at the book. It says cost versus volume for 10 hand soaps. And on the vertical axis, we have cost at dollars. The baseline is a 0. Next line is $1. Next line $2, $3, $4, and the graph stops there. On the horizontal axis, we have volume in ounces, also beginning at 0. Next line is at 5 ounces, then 10, then 15, then 20, then 25, and the graph cuts off at 25. Does the line in the graph actually go from the lower left all the way up to the upper right, intersecting the 0 point? Yes, it does. And intersecting the $4 and 25 ounces point? Yes, it does. Does that matter? Yeah, it does. I'll explain why. For 10 bottles of hand soap of various brands, the cost and volume of each are displayed in the scatter plot above. And the line of best fit for the data is shown. Okay. Of the following, which is closest to the average or arithmetic mean cost per ounce for the 10 bottles? Okay, now what I mentioned before is the line actually goes from 0, 0 to 4 and 25. The other points don't intersect any of these integer convergences. The line goes underneath $1 at 5 ounces. It goes underneath $2 at 10 ounces, etc. It does not. There's no clear intersection point there. But the 0 and the 4 and the 25 they're pretty clear. I know the next question. Teacher, there's no data down at 0. How can we use that? Well, if there were data, that's what it would be. The line is an abstraction. Arithmetic mean is an abstraction. Okay, we're looking for abstract data based on these dots, which are supposed to represent real data. Okay, and so there's that the 4 and the 25. Teacher, there's no data at 4. I know. There's just a line, but the line continues. It goes through that bunch of dots, but at each end it actually converges with these easy intersections, and you should take advantage of that. Okay, so average arithmetic mean per ounce for the 10 bottles. I think the only way that you can go about this is to take that 4 and that 25, because if you divided the $4 by the 25, okay, you would get the same thing as if you divided everything else by everything else down to the 0, 0. The 0, 0 doesn't matter, okay? But it is there. It tells you that's where the line begins. If you buy nothing, you pay nothing. That's what the 0, 0 tells you. Okay, it doesn't look like you can buy, 1 ounce. But if you could, the function would be described by that line. I know I'm over-explaining it again. I love to over-explain things. So what do? We take that 4, even though there is no such bottle, and we're going to run that through getting my calculator up here. You may be able to do it in your head. I'm just going to do it on a calculator to see what actually happens. You have $4, that's 400 cents, divided by 25 ounces equals, looks like 16. 16 cents per ounce would be the closest thing to any of these answers. Look at these answers. It says 10 cents per ounce, 15 cents per ounce, 19 cents per ounce, and 20 cents per ounce. And I know in previous problems where I've mentioned the difference between precision and accuracy, that has confused people because aren't precision and accuracy the same? No, they're not. Okay, the 15 cents is an approximation of the 16 cent figure, so it's rounded down. It's rounded down to the nearest 5, I guess. It would be either rounded up to to a 0 or down to a 5. The 19 cents per ounce is not rounded, but it is also it's also the wrong answer. It's further away from 16. 15 is closer to 16 than 19 is. So despite the fact that 15 has been rounded and 19, if it's been rounded, has been less rounded. It is rounded from something that is less accurate. So answer C is, in a sense, it is more precise, but answer B is actually more accurate. Wow. Okay, answers A and D, you know, I don't care about that. It's almost always answers B and C that are going to be interesting to me. If things that I've said about this are confusing to you, please tell me. The difference between precision and accuracy, it matters to me a lot, and I don't see other math teachers talking about it very much. Maybe because they're math people, not science people. I don't know. In any case, let me know, because this one is a great example of that. Let me know.